Hello 12th standard students, welcome back to chapter 4 inverse trigonometric functions. Today we are going to see some concepts, then we'll go into our problems. First comes the periodicity. The real valued function f is periodic if there exists a number p greater than 0 such that for all x in the domain of f, x plus p is in the domain of f and f of x plus p equal to f of x. Okay, so this is the only concept we are going to see now. The smallest of all such numbers is called the period. Okay, we'll see what is a period. For instance, they are given sin x, cos x, cosecant x, secant x and e power ix are the periodic functions with period 2 pi. And whereas 2 pi radians, whenever you tell in pi, you should tell it as radians. Whereas tan x and cot x are periodic functions with pi radians. Okay. Now we'll see how we are going to put the sine graph. Here I have given the trigonometric values. See, sine starts in 0. For 0, it is 0. Okay. Then, and 30, 45, 60, and in 90, it reaches the height. So, here pi by 2, it comes to 1. Okay. Here it comes to 1. So, from here, the curve comes like this. Okay. So, from here, it goes up. Here, 90, it reaches the maximum 1. And again, from 90, it comes down. Again, when it comes to pi, see here, this is 90 and this is 180. In 180, it goes to 0. So, from here, pi, it reaches the maximum and comes down to pi. Okay. It is a smooth curve like this. It comes to pi. Again, from pi, in 360, it comes to 0. See the sine curve? So, again, it comes down. Here you will get a minus 1. Here you will get a minus 1. See? Sine curve when it comes down. Okay. So, at 3 pi by 2, it will be minus 1 here. So, again it reaches here. So, from here, from pi, it comes down like this to, here 3 pi by 2. Again, it goes to 2 pi. For 2 pi, it is again 0. Okay. So, these values you are taking. So, this is the curve. See, here from pi to 3 pi by 2 comes like this and then it goes to 2 pi. Okay. So, this sine curve repeats the same. Again, from 2 pi, it goes up to 1 and then again. Similarly, negative side also. Here at pi by 2, it comes to minus 1 and then goes to pi and then to 3 pi by minus 3 pi by 2 and again to minus 2 pi. So, this is the curve. Okay. So, this is called as the sine curve and this period from here to 2 pi. This is called as the period. Because the same cycle it takes. This side also 2 pi, this side also 2 pi, even in the negative or in the positive. Again, one more 2 pi, it completes one curve. Okay. That's all I have given here as graph for you here. Here it is period. So, this period, this is the period. One curve, one complete curve or one complete cycle is called as the period. Okay. I have given the trigonometric values also for you. And here for cot x, you see for cot x, it is pi, this distance from here to here. Okay. So, 0 to pi. So, this is pi and this is 2 pi. Okay. And so, for some functions it is 2 pi and the other functions it is pi. Then the period is the distance required for the function to complete one full cycle. So, this one full cycle where from 0 to 2 pi, this cycle, this full cycle is called as the period. Okay. And then now come into odd functions and even functions. A real valued function is an odd function for all x in the domain f for f minus x is also in the domain of f such that f of minus x equal to minus f of x. You take the function f of x equal to x power 3, you will get put f of minus x then equal to minus x the whole power 3 odd power, so you will get minus x cubed. This is nothing but equal to minus f of x. So you are getting here f of minus x equal to minus f of x. Similarly, they are given some examples sin x, cosecant, sin x also. Sin x also, how can you write? Sin of minus x equal to minus sin x. This you have seen in your 11th standard trigonometric functions. Okay. And for even function, it is f of minus x equal to f of x. When you take f of x equal to x square and f of minus x equal to minus x the whole square, again you will get x square, that is equal to f of x. Similarly for cos x, f of x equal to cos x. So cos of minus x is equal to cos x only. So this is again going to be f of x. This is f of minus x. Okay. So in the same in the 11th standard you have seen. So sin of minus x is minus sin x and cos of minus x is cos x. Okay. So using this, you see even in odd functions. So this point you have to remember, this is for odd and this is for even. Okay. So the graph of an odd function is symmetric with respect to the origin. So this is the graph. So this graph is here through the origin. Here also it is symmetric, here also it is symmetric. So you can transfer this curve here, it will come like this. It will be symmetric. Okay. So it should come like this. And when you transfer to up, it will go like this. Okay. Origin means it should be symmetric on both the axes. Okay. Y-axis as well as x-axis. Whereas the even function is symmetric about the y-axis. See, this distance is equal. So when you take this curve, this side, it will be of same. It can be when you fold this paper, and when you fold through this line, this curve will coincide with this curve. Okay. So this is how it is. So this point, even function for y-axis and odd function to the origin. These 2 points you have to remember. And what is the amplitude of a graph? Amplitude. What is the amplitude? So we saw the sine curve, isn't it? It is starting from 0, pi by 2, and then comes to pi to 0, again to 3 pi by 2, it comes down, and again to 2 pi. So the maximum length, this length, this is called as amplitude. Okay. So the amplitude of the maximum distance of the graph from the x-axis, from here, amplitude is the function, is the height, it's only the height, okay, height from the x-axis to its maximum or minimum. So here the maximum, so maximum is 1 on +1 and -1, okay. So this is how we measure the amplitude of the graph, okay. Thank you.